Hey everyone, I'm Suneet Agrawal, part of Gamescraft. I work there as an engineering manager. It's been almost 10 years I'm writing code or managing people. So today here I am to discuss about the camera APIs as well as OpenGL. We are going to discuss about both the things individually, and after that how can we combine them and we can leverage the power of it. Okay, so stay with me till the end. You are going to learn a lot of things related to camera today. So before that, I'll tell you the agenda, what all things we are going to discuss today. The first thing we are going to talk about is what are camera APIs, what all different versions do we have, and from which API version do they support on different Android. Okay. After that, we are going to talk about a process called rasterization. Okay, that is the process I'm going to talk about in detail. How the objects or the frames are drawn on the screen of mobile Android device. Okay. The third thing I'm going to talk about in detail is how GPU is involved there. Okay, in terms of drawing your frames, how GPU is going to take over and going to manipulate your frames. Okay, then we are going to talk about the OpenGL. What is OpenGL exactly? Does your Android phone has that OpenGL? If particular one, which version does it have? Okay, and how can you leverage it? Okay. After that, we are going to talk about what are vertex shaders and fragment shaders. So these are basically required to manipulate every frame. Okay, maybe beautification, maybe some effects or something. So we are going to talk about that. We will along with some examples. Okay, and at the end we are going to talk about the real life use cases. How can you implement it, or how can you leverage it? These two things, the camera APIs and OpenGL, into your application. Okay. But before we start, let's talk about the camera needs. Okay, I'm pretty sure from last 2 days everybody is asking for your scanning the QR code, right? That is again a part of camera process. We capture an object and we try to process it. Okay. Apart from that, think about social media apps. Okay, where everybody want to click a selfie, they want to post it, or maybe in a normal application you ask for a profile picture, right? Nobody is looking for a very basic one where there is no filter, nothing. People usually look for maybe some banner at the bottom, or maybe some cool glasses, some hats. Okay, so yes, we agree with this thing that almost 70% of the applications uses the basic camera, where they just need a camera profile picture or something, and rest 30% are either social media or something that they want to manipulate the images, maybe a live streaming or something like that. Okay, where they kind of some beautification they want to provide to the end users. They want to provide some filters, they want to provide some objects, random objects which can be visible on the screen on the camera feed. Okay. On top of that, there are a few features which are already there, like think about night mode, which can actually brighten your image, the camera preview. Okay, there is something called bokeh effect, which is nothing but when you have two different cameras in a particular device, the one with different focal length will be focusing on the background and will try to blur that background on the left image. If you see the image, the background is blurred, but the another camera or the another lens is focusing on the another front object, right? So if you see that particular image, this is called bokeh effect, where the background is blurred and the object which is in focus will give you a live effect. Okay, on the right side we have a very simple night mode image. Very simple. When you talk about this, it just gives the brightness to your preview and the image at the end. Okay, so social media, when we talk about so people in the social media apps, you have these kind of effects where night effect is there, bokeh effect is there, you have some stickers, you have some filters and much more. Okay, now the question comes in, what Android provides us and what as a developer we need to do. Okay, so let's talk about what Android provides us. Okay, so Android provides us a simple application which is camera, which you can trigger using intent, and it'll actually capture the image for you or maybe a video for you. It actually manages the life cycle as well for you. Let's say if since we have only single hardware which can be shared between all the applications, the camera hardware, so it's going to manage the life cycle for you. It'll actually free that device and it'll give you to some other application if somebody else requested for it, right? So it actually manages the life cycle for us. It actually controls the front camera or back camera. Let's say if you want to switch between these two, it's very simple. When we talk about it, it's just that you need to initialize the camera and you need to flip the camera. That's it. Very simple, right? So at the end, when we talk about the Android, what Android provided us, it actually provided the camera application which you can trigger using an intent, and you can either get an image pack or maybe a video pack, right? Now, let's talk about the camera APIs. What do you have all from the Android? I think we all know that we have 3 camera APIs, but I'm not going to go into details because this is not about which camera APIs we are going to use, but we are going to talk about in general. But let's have a look at least what all APIs do we have. So we have camera 1, which is there from a long time, okay, which was there. Now it's deprecated, people stopped using it. Then we got camera 2, which is above API 21, which is Android 5.0. Okay, and the latest one is Camera X. Okay, Camera X is very powerful. I personally used it. It's still they are still developing, and they're enhancing the features, but I really find it very powerful. When I talk about Camera X, Camera X gave us direct features like HDR mode, okay, face retouch, bokeh effect, and night effect. These effects are already there, so you don't have to do anything much. You just trigger your camera and maybe you can click an image. But we are going to talk about how can we combine this to an OpenGL and what all can we do. Okay, so majorly we are going to focus on Camera X only, if there is anything, but Camera 2 is also there, but both are from Android API 21, but Camera X is way more powerful. Now, can a camera API click picture? Very simple question. I mean, if my application just want a profile picture, why should I be bothered about what is OpenGL and what should I do with that? Okay, the question is very simple. If the camera API can do it for me, why should why should I be bothering about this? So yes, the question is right. The answer is very straightforward. Yes, it can do it. Like I mentioned before, you just need to trigger an intent and start any activity or any application which supports that is going to catch it. The application is going to click an image for you or maybe a record video for you, and it'll give you back the path of the image or the video, right? Very straightforward, but you cannot do much there. It's not like that you can put some filters there, or maybe you can draw anything there, right? So at the end, we are losing the power that we have as a developer or as what we can provide to the end user. Very straightforward. It's just that I need a click. I want to click a profile picture, I'll trigger an intent, I'll get the image back. That's it, that I can upload to my server. Now think about the applications who want to actually leverage the power of OpenGL, right? Where think about major use cases, social media apps. So we are going to look at the use cases, but yeah, we don't want to lose the power. Then we need to have a look about what all can we do. So yes, when I talked about yes, we lost the power when we asked the API to click a picture for that. Actually, we lost the power. What do I mean by that? Okay, so look at the left side process. The left side one where we did is from our application we just triggered an intent, and the application, mostly the camera application, default camera application, is going to catch that. It's going to click a picture for you. I'll first show you the preview. Okay, the user it can click a picture, it can record a video. The user can flip the camera from front to back, and they can click a picture, and at the end we are going to just get the URL or URI of that particular file. Okay, but when we talk about let's say if we want to take a control, let's say we are just going to get the raw frames from the hardware, we want to show it in our application, the preview. We want to capture the application and show it to the end user. In that case, we need to take the control of the entire flow. Okay, what do I mean by that? I'll have that detail in the upcoming slides. Okay, before that, let's before I get into detail about how do we get the frames from camera and how do we preview it on the screen, before that, let's talk about how the in general drawing of any frame on the screen works. Okay, it's very simple. When we talk about a recycler view, when we talk about any layout, okay, then it's not something that will be visible to the or this is not something that our GPU understands. Okay, GPU only understands pixels. When I say about pixels is nothing but polygons, very small polygons, which will be filled by multiple colors. Okay, so if you see at the screen right now, when you think about a button, how that button will be drawn on the screen, it's nothing but when you see at the bottom side, it's small triangles, which we call it low polygons. Okay, and each and every polygon will be filled with some colors. Okay, so this works on polygons. Anything which you see in your device works like this. It's never visible like recycler view or something. That is only up to CPU. After that, when it goes to GPU just converts it everything into multiple polygons and show it like this. Clear example of this button. This button is divided into multiple polygons, and those polygons will be filled by colors. That's it. Now the question comes in, what is OpenGL and how that is going to help me out in terms of manipulating the camera frames and all those things. Okay, so what is OpenGL? OpenGL is cross-platform API to render 2D objects and 3D vector graphics. Okay, anything that you see on your screen is still managed by OpenGL. Okay, if you are aware or not, but at least any phone has an OpenGL. I'll show you the details. But yeah, anything that is visible to your screen is not managed by CPU, but that is managed by OpenGL. It's just that, very straightforward. Whatever you see is OpenGL. Okay, this API is actually used to interact with the GPU for drawing anything on screen. Anything that you see on your screen is managed by OpenGL, whether it be a button, whether it be a recycler view or any other layout, right? So maybe similar way the camera preview can also be seen, just that we want to manipulate it. Okay, so yes, below are the OpenGL versions. So Android uses the embedded system version, OpenGL ES. We have different versions. I think 3.2 is the latest one. But again, at the end, it's not a guarantee that every phone has the latest one. Nowadays, everyone is coming with more performance optimized and all. So yes, we do have mostly on 3.0 above. Okay. Now, I mentioned about a key term called rasterization. Okay, so what is rasterization? We might need this to understand in order to understand the further slides, that how can we manipulate the camera frames in order to achieve our filters and other things, right? So what is rasterization? It's basically taking process of taking objects like buttons, shapes, and turning them into pixels in the texture on the screen. Like I mentioned, anything that you see will be drawn using very small pixels. That's the reason you get okay, how many megapixels is your camera is, or how many pixels are there in your screen, right? So the more number of pixels, the better quality of your screen will be. That's the reason more pixels, it's more quality, right? So yes, converting shapes into small polygons, like I mentioned, and filling polygons with colors, which is nothing but your pixels on the screen. Very simple, straightforward. Now, anything that you see is directly that. When I talk about camera is also converted into similar fashion, where you get each and every frames. Maybe the best case, you'll get 60 frames per second, and you are going to preview that on your screen. So that is again drawn using those pixels, very small pixels that give you the quality of your image. So similar way, I'm going to explain the rasterization. On the left side, you have a very black and white polygon, which is an image of fish. Okay, and the right side you have the colors that need to be filled in that. Okay, this all comes under CPU. CPU is going to do all the manipulation. CPU is going to just do all the calculations. Let's say if we say we want to show this image view, and this image need to be shown there, right? So at the end, CPU is going to pass everything into GPU using OpenGL. Okay, and OpenGL is going to do the visibility part, where it will be visible to your screen. So at the end, it's a lot of process on the GPU side. Okay, in order to show each and every frame on your screens. Now, how GPU is involved, that question comes in, because again, at the end, anything that need to be in order to be calculated, that is done by CPU, right? So GPU is nothing but the process of rasterization is managed by GPU. The process of drawing anything on your screen is managed by your GPU, right? So GPU is is designed to use specific polygons and textures. Let's say if you want to change any color of a button, maybe a color of background or anything, that data need to be passed to GPU, and GPU is going to draw that on your screen, right? Now, in order to preview the camera view, the camera, basically the feeds that you're getting from the hardware, there are 3 different views that you can use in order to preview any camera frame. Okay, among these, the first one is surface view. It's the oldest one, which older phones were using. Nowadays, nobody uses it majorly, but it's still there. Okay, so again, very limitations were there. Okay, cannot be moved or animated as it opens in a new window. Older phones has it. I don't remember I'm using it anymore now. Okay, the second one is texture view. Texture view is something that cannot be moved. When I say moving, it's about the objects that are moving inside. It'll be still. Okay, so cannot be moved and animated because this requires hardware acceleration. I'm not sure if all of you have heard about hardware acceleration or not, but in the manifest file you need to define it, whether that hardware acceleration is required for you or not, right? The third one, which is really popular one, is a GL surface view. It's an implementation of surface view that uses dedicated surface for displaying OpenGL rendering. Okay, so we talked about a lot of things. We talked about camera APIs. Camera APIs are nothing but that gives you the frames, maybe 60 frames best case in a second. Okay, second thing we talked about OpenGL. OpenGL is basically for drawing the feed on your screen, right? So we have two building blocks. One is to get the to capture the frames from your hardware. Second thing is to draw your frames on the screen. Now, what all can we do in between? Okay, so we got the frames from hardware. We want to show it to the end user, but we want to manipulate it in between. Okay, we want to show it some kind of effect, maybe black and white effect, maybe some CPI effect or something, some grayscale effect. Okay, so we want to actually manipulate all the frames that are going to be visible on the screen. So we are getting the frames from hardware using API, camera APIs, and we are going to show it on the OpenGL using GPU. But we want to, in between, we want to manipulate each and every frame, right? So can we manipulate it? Can we process it? Can we detect a face in between? Let's say I want to show some cool glasses to the end user. I want to detect the face and I want to show the cool glasses on the user face. Second thing, I want to change the background. Okay, I don't want to be visible in this area. I want to be in some other space or something like that. So I just want to detect the user who is in the front. Backside, I completely want to change it. So these kind of use cases usually comes in. We have other applications as well who are doing this, but let's assume we want to do it. Okay, so yes, we are getting the frames. We want to detect the object inside this, and we want to do any kind of manipulation. We want to put some object, we want to detect a face, we want to detect a QR code, or maybe anything. Okay, then question comes in, how can we do it? Okay, if we got the frame, if we got the frame from the camera, how can I manipulate it? Okay, so the answer lies between how OpenGL works. Okay, if we understand that, we will be able to at least manipulate each and every frame very easily. So when I talk about OpenGL takes inputs in two format. Okay, one is vertex shader and second is fragment shader. Okay, when I say what is vertex shaders are nothing but arrays which are going to define the places from which all the polygons are designed. Okay, very straightforward, which object is starting from which particular coordinate and which is ending at what coordinate. Okay, it's not about the entire object, since they are divided into multiple polygons, so you have a lot of data. When I say about fragment shaders are nothing but which color need to be filled inside that particular polygon, or let's say inside that pixel. Very straightforward, which color will be filled. If you can manipulate that, you can definitely convert your image into anything else. Okay, so GPU or OpenGL takes inputs in two format. One is vertex shader and fragment shader, both at the same time. Okay, now look at how can I manipulate the camera preview. So this is one of the example, very straightforward, very basic. Okay, this is a fragment shader that I can pass to OpenGL. Okay, when you see the yellow color code, there are three lines, which is color R, color G, and color B. Okay, these are very basic primary colors. What I did is basically I added them and divided it by 3. So I just converted each and every scale into 0 to 1, a combination of 3. So when I add all 3 colors on 100%, you will get a black color. When I add all 0, I'll get a white color, right? So the output will be very straightforward. You get a preview of just black and white image. If I go back and if I look at the code again, it's simple. I am just adding the R and G and B, the red and the blue and the green components. I'm just adding them and passing this into my fragment shader, nothing else, right? So very straightforward code, very small, and at the end we are getting this particular output. It's not only one image, it's the entire preview of the camera that you are getting. Okay, so in this camera preview, instead of a natural image or the camera natural preview, you are getting a preview of basically black and white image. Very straightforward. Let me show you some other example. Okay, in this we are just inverting the color. When I say inverting the color, I'm just subtracting the actual color value, which is between 0 to 1. I'm subtracting that from 1. Okay, so a black color will be converted into white color, a combination of other colors will be converted into the inverted color. Okay, if I see the again yellow color code, it's very straightforward. One subtract the color component, the red color, the blue color, and the green color, and I'm passing that again to the OpenGL. Okay, output is very straightforward. Actual image is to the left side. To the right side you have inverted preview basically, which will be visible to each and every frame on your process. Okay, so any camera preview that you see, you can apply this inverted color. These were the very basic filters that you can because the code was very simple, but using a lot of manipulations, using a lot of calculations, you can come up with any possible filter, right? You can have a particular area which will be just blurred. Okay, you can have an effect at the end which can be visible on your camera preview. So then these kind of preview that you can provide if you take a control of drawing the camera frames which you are getting. Okay, these are not just the limitations or again there's no limitation there. It's just that whatever shader or whatever filter you want to draw, let's say if I want to change the background, just that I need to manipulate my fragment shader, whatever I'm passing it to my GPU, and that will take care for drawing all the things. So code is not that difficult if you see, very straightforward outputs, but every frame will be manipulated and every frame will be visible like inverted color. Now the question comes in, these were very simple filters. How about adding an object? Maybe a funny person jumping in front of my screen, let's say I'm visible, or let's say I want to send a very funny video to my friend. Okay, my eyes will be bigger and all those kind of face features I want to change. Okay, so the question comes is, can I add custom objects on that? Okay, maybe I want to add a cool glasses, or I want to add a hat on my face whenever camera preview is visible. I'm pretty sure any social media you might have tried which is doing that. We have a lot of social media apps who has those kind of cameras where they put a lot of objects on your face. Okay, after detecting the face points, they just put the other objects on your face, right? So yes, we can actually process the frames we get from the Camera API. It's just that you need to see the limitation, because if your phone is really high end and you're getting 60 frames per second from your hardware, you cannot manipulate each and every frame. We are going to talk about the limitations there in the upcoming slides, but you'll definitely see some kind of lag because we cannot process each and every frame in a second. Okay, whatever frames you're getting, you cannot process all frames in 1 second. Okay, so we are going to talk about that, but definitely we can figure out the background, we can figure out the objects in the image, we can process the face, we can do any kind of manipulation in terms of adding the object, right? Since we get the coordinates of object in the preview frame, we can add our object in that particular frame as well. So maybe I want to add a table on this thing. I'll show you the real life examples, but yeah, I can do anything in terms of, okay, I want to do this particular object on all the camera frames, right? So those again, along with the limitations, you can achieve all these things. Definitely we are going to look at the real life cases, but yes, adding an object to a camera preview is possible. Now the question comes is this efficient? Again, processing each and every frame that you're getting from the Camera APIs, where you are going to take the control for previewing it, okay, on your OpenGL using GL surface view, right? Is this efficient? Is this efficient to actually process each and every 60 frames that you're getting from the hardware? See, again, technically it's not possible. So what do people do is basically they skip some frames. Maybe they just process 2 or 3 frames within a second. They try to figure out what is the maximum change. Okay, that's the reason there is some delay when you try those social media apps and it try to detect your face. It gives you some delay because they also process 2 to 3 frames within a second. After that, they put some object maybe on your face, maybe they'll put some mustache or something like that, right? So that delay is basically, a reason being behind that delay is because you cannot process each and every frame. That's the reason when we process, when we scan any QR code, it takes some time to process that and it gives you the output after that, right? So yes, whenever you draw a sticker also on a camera preview or the live preview that you see, it takes some delay because not any app can, it's impossible to process 60 frames, right? Our devices are not capable for that, but at least if you write the right algorithm, if you skip the right frames, okay, maybe by processing 2 to 3 frames maximum per second, you'll be able to achieve the best result. Now, can we record? So it's all about, so far we have seen that we are getting the frames from the camera. We are manipulating them. We are putting some vertex shaders or fragment shaders on top of that. And we are showing it to the preview. Okay, we are getting the frames continuously. It's getting manipulated and it's visible to the screen. Now the question comes in, I want to actually record that video. Okay, in the output also, I want the same kind of effect or maybe the same stickers or something like that. So the question comes is it possible to record those manipulated frames? Since we are able to detect the object in the frame, we are able to add the object on top of that. Once that is done, I actually want the output or the image or the video completely with that particular effect or with that particular object in the frame, right? So yes, anything that gets manipulated is stored in a form of byte buffer. So you can record it and you can export it in a form of any image or maybe in a format of video, right? So anything which is visible to your OpenGL screen or anything that you manipulate can be recorded. A video will be along with that particular filter or anything that you added on that frame. So these are real life examples. If you see, this is a video call screenshot. If you see here, a lot of people have added some objects on the frame. On the left side, second row, the face was detected, then the glasses were added, okay, and there was something added at the head, okay. If you see on the second row, second column, okay, the background was completely detected and changed into something else, because at the end you need to detect the object where is the face. Except the face, you just need to change everything. So this is easily achievable using the fragment shader, right? But it's just that whatever feeds that you are getting from the camera, you need to manipulate it. You need to figure out the object within that, maybe face, maybe some surface or something like that, or maybe background, and you need to change that, right? So this is very straightforward use case where you want to add some beautification, you want to add some object into your camera feed, and you need to pass it to your server, right? Think about other use cases nowadays. E-commerce, very straightforward use case. I want to try even before buying anything, right? Whether how this object is gonna look in my world, right? Whether this gonna look good or not, I want to try it in my space. So this goes majorly into AR VR, but when we talk about this particular camera thing, it's about, at the end, it's about detecting the object, the corners. Then you need to place that object on your particular surface. So if you see on the left side, there's no table lamp on the background, but when we see in the preview, you will see it along with the table lamp. So yes, very good use case for e-commerce. In order to sell your things, you can detect the face, you can detect the object, maybe you can place it in your real world, and the user will be able to take a feel at least before buying that. Another use case, basically you're getting the frames from the camera, you're getting the text in another language, right? You're just trying to detect the objects inside that. You're just trying to detect the text which is there in all the frames, okay? Once you detect the text inside that, it's easy to convert, because we have, we have Google APIs and other APIs which can basically translate one language to another language, right? So just that, whatever feeds that you're getting, a lot of applications are doing that. If you think about Google Lens, they are doing it very easily. Similar way, so basically they're getting the camera preview, the camera frames, they are actually detecting the text inside that, and they are converting into some other language. So yes, same use case, you're getting the preview, and instead of passing it to another application, you're processing it, you're trying to extract the data out of it, and you're putting the text on the same object which is already there, right? So it's adding an object, or basically a view on top of that. Now think about the possibilities. Okay, possibilities are endless. When you get the complete control of all the camera frames, you can do anything that you want, whatever be your use case. It's just that you need to write it, put it in the right shape, right? So think about any use case that you're getting from the camera, you just need to manipulate right, okay, whatever is your use case. So all kind of image processing is possible. You can change the background, you can change the video feed, you can record it, you can save it, you can do anything. But again, the question comes in, so there is a great saying, with great powers come great responsibilities. So think about what is your use case, okay? Think about what are your end users, what devices do they have, okay? Not every phone is able to process 60 frames, okay? Not every camera is able to provide you a feed with 60 frames. Even some devices provide you like 45 frames per second, right? So first think about what are your audience, targeted audience. I mean, which phone do they carry maximum? Okay, is their phone capable enough to handle all these things? Because at the end, redrawing or finding objects within a frame, that to a continuously ongoing stream, it takes time to actually process that frame, right? So think about this first. What is your use case? Okay, is the audience, the device that your audience is carrying, is it capable enough to handle these things, right? So any manipulation, you need to think first whether my targeted audience is going to get the benefit out of it or not. Think about social media apps. They want to support all the filters, but not every phone is supported, right? That's the reason they limit some filters for the high-end devices and some filters only for the low-end devices, right? So that completely depends on device to device, but at the end you need to think about writing any manipulation, okay, on any device. You need to think about it whether that particular device will be able to handle it or not, because you're getting continuous frames of the camera feed. You need to show it on the preview. Before that, you want to manipulate it. So think about it whether hardware is really capable of that or not, right? So this is the last slide. This is the takeaway. Basically, what we can do almost anything if we decouple the camera APIs and the preview. Okay, in between you're getting the frames from the camera hardware, you're getting all the frames continuously, and you want to show it to the end user on the screen. Before that, you take a control, you actually manipulated those using fragment shaders and vertex shaders. You can actually in between figure out what are the objects inside that, maybe the background, maybe the face, maybe anything else. Okay, if you want to add an object on top of that, maybe if you want to add a table lamp on the table, maybe if you want to detect a text inside that, you can do it in between. Okay, but keep in mind again, there are some limitations. It completely depends on hardware. Is the end user hardware capable enough to handle this? Okay, you're getting maybe 60 frames, maybe 45 frames per second, so it will be too much calculation for the CPU in order to detect that and at the end pass the data to GPU, right? So OpenGL is something that helps in drawing anything on the device screen. Don't think about only camera, but anything that you see on your screen is drawn using OpenGL. Without OpenGL, nothing can be drawn. Okay, and you can write your own custom vertex shader and fragment shader, which is basically the format in which OpenGL or basically your GPU takes the input. Basically it will be drawing based on that particular data, so you can write your own custom vertex shaders. It's just that each and every pixel will be manipulated based on that. Okay, so you can write your own code which will be manipulating each and every frame before previewing it to the end user. Now once that particular manipulated frame is visible to the end user, you can record it in a format of video, or you can take a picture of it, and at the end you can post it to some social media. You can leverage it on your application, maybe profile picture or something. So yes, very straightforward. It's just that everything, if you take the control of previewing things and everything, if you take the control in your hand, you need to be very sure that there are some limitations that you need to take care for the hardware limitations side. But yes, the possibilities are endless. It's just that you have to take the control completely and you have to manage things on your own. So that's all from my side. Okay, if you have any questions, I'm available. I'm available here as well. Okay,